Okay, dear student, let us see what is there in this question now. The Feynman diagram shows the delta baryon decaying into the neutron and a particle X. The exchange particle involved in the decay is a gluon. Okay, now that's a quite different thing. Like it's a big surprise to me. Why? Because in all of the books that they have given, like you can refer to any, but they have not shown any Feynman diagram with the gluon or something. There are very less examples that are given in regards to gluon or the mesons or something. But still, no problem. We will do it. Particle X has two constituent quarks. So this is having two constituent quarks. So first of all, there is no such particle which is having two quarks other than the meson. So definitely this is going to be a meson. So one will be a quark and another will be the antiquark, you can say, isn't it? So we can just say Q and we can take it as Q bar, antiquark. Identify the fundamental force responsible for the decay. So my dear student, first of all, because it is using gluon, so clearly gluon is used for the strong nuclear interactions. So answer number one here will be the strong nuclear interactions, no doubt about that. So the exchange particle should be either gluon or a meson, then it is a strong nuclear reaction. Otherwise it could be having W negative, W positive, or Z zero. This is for the weak interaction. So if this kind of thing is happening, it is a weak interaction. But we here it is a gluon. Deduce referring to one conservation law that X is a quark antiquark pair. Okay, so that I have already told you that according to the philosophy that that the quarks, when they're coming together and making a bigger particle, only three type of particles can be created. So the first is the baryon, and in the baryon it is using three quarks. All those three are the quarks. Then there is something called antibaryons. Antibaryon is that when you use the three antiquarks, so that is the antibaryon. But here there are only two particles, and the third category, the only third category is meson, in which one is the antiquark and the one particle is the quark. So at that time quark and antiquark, they're coming together, so that is meson. So clearly from the diagram it is 100% sure that yes, it will be a meson, there is no doubt about it. But they are telling you to refer to some conservation principle. So we can go for the baryon number, because for the meson the baryon number is 0. So the reaction can be written as delta, it is converted into neutron, and it is giving some particle X, let us say. So the baryon number for this is 1, and the charge for this will be something. Uh, but anyways, it is the down, no. So down will be negative 1 by 3. I think. Okay, no problem. We will not be talking about the charge. So the baryon number for the delta is 1. For the neutron, it is again 1. And for the meson, it is 0. So we will say that according to the Feynman diagram, we can write the nuclear reaction. And by the conservation of the baryon principle, we come to this conclusion that the baryon number for the X should be equal to 0. And that is possible only in the case of meson. Why? Because it will be having one quark and one antiquark. So the baryon number for the quark is plus 1 by 3, and the baryon number for the antiquark is minus 1 by 3. So overall, the baryon number for the meson is always 0, and that is why we are sure that X will be a meson. So you can use the conservation of charge principle also here. I'm not sure about up and the charge on the up and down. I'm just missing it from my brain. What was it? Not able to remember. It was plus 1 by 3 or minus 1 by 3. So that is why I don't want to get into the conservation of charge principle. But otherwise, if you remember, you can apply that also, and you would be getting the right answer with that also. Let us see what they have done in the mark scheme, and we will then move for the next question. Yes. So 10.1 is the strong nuclear forces. Attempt to apply the conservation law of the baryon number, that is the alternative 1, and this is what exactly that we have done. Alternative 2 is the conservation of charge. So that can be applied, but because I was just missing, those things were missing from my mind, so I have not applied that. Otherwise I would have explained you the alternative 2 also, but I believe you would be in a position to do this question by yourself. Alternative 3, okay, anyways, attempt to apply the baryon number or the charge on each vertex. Okay. Uh, Let us go for the 10B part now. What is that now? The energy released in the decay is of the order of 10 raised to power 8 ev. Estimate using the uncertainty principle the mean lifetime of the delta baryon. So this is basically the uncertainty principle, Heisenberg's uncertainty principle, and it is having the formation of delta E into delta T, which is greater than or equal to h by 4 pi. So usually I say that from the uncertainty principle, only two formulas are there, like delta P into delta X will be greater than or equal to 4 h by 4 pi. So either you would be getting a question from this, or you would be getting a question from this. And that is why you just need to substitute the value and get the answer. There is nothing that you have to explain or something. So E is 10 raised to power 8, but because it is EV, we have to convert it into joule also, because everything here is in SI unit. So this is delta T, which can be taken as mean lifetime for the delta baryon, which is greater than or equal to this. So the value here is 6.36, 10 raised to power negative 34. This value is 4 pi. From here, we will find the value of the delta T, which can be taken as the mean lifetime of the delta baryon. Need not to go into the understanding of that, like what is the concept behind it, how are we going to explain the things actually from the point of view of Heisenberg's uncertainty principle. We are not going there. We just know that this is the formula given in the data booklet. Apply the value, get the answer. That's it. So this is delta T. So this is how we do this question. Let us see what they are doing in the mark scheme. I believe this is going to be the last question. Yes. So 10 raised to power 8, this is converted into joule, and it is equated with h by 4 pi, and there it is. You have the answer in seconds. So exactly this is what we have done when I was giving you the explanation. So this is how we do this. So my dear students, we have completed the question paper now, the November 2022, I believe. Yes. So this question paper is over. So later we would be moving to some other question. Okay, then see you. All the best. Bye. Thanks for joining. Please share the video with all your friends.